All right, first off, every good plan for wiring starts with a diagram. You gotta start with the diagram. I know my diagram's not pretty, but it's okay. So this is my wiring diagram to hook everything up to a wired switch box, along with all the proper connections from the power source, the grounds, fuse box, and relays. I'll run you through it now. So we're gonna start with just kind of a general census on what's going on here. So I have an air compressor, a radio, front light bar, rear light bar, left alley, and right alley. Also, this is on my 2001 Subaru Forester. I love that drawing. Looks pretty detailed. Uh, so everything starts with a good power source. I currently have a 2.2 farad capacitor in my car, but I'm upgrading to a 4.4 that I have sitting in the bedroom. The 4.4 capacitor is already hooked directly to the battery by a positive and negative connection. The positive connection is going to run to a fuse box, and the fuse box has its own dedicated power, and the fuse box will also be grounded to the frame, so it'll have its own dedicated ground. From there, the fuse box on each individual fused connection will feed the relay box, and the relays control each individual connection for things like the light bars and the air compressor. So if you understand anything about 12 volt power, relays are simply like electronic switches. Once a certain 12 volt power is applied, the relay then turns around and kind of provides an extra level of protection on electrical circuits, but the relay turns around and switches another connection telling the power and ground to turn on, essentially, which powers your item. So what exactly I mean by the last slide is you're going to have a 4 or 5 wire relay, and on this application we're using all 4 wire relays. On a 4 wire relay you have a power and a ground coming from the fuse box. Well, the power and ground relays will then in turn have 2 other wires that run to your switch. The mechanical switch controls the power and ground for that particular circuit. Relays also prevent that particular circuit from being overloaded with a surge of power. So from the relay box we move all the way up over here to these switch box. These are the mechanical switches I was talking about. And so what happens is you have a wire from the relay, and that wire from the relay does manage to have some 12 volt power being passed through, but it's just like a hot side on a battery. And so you hook the one side to the one side of your switch, and the other connection runs all the way back down to the other side of the relay. And when you flip this mechanical switch, this relay turns on and pulls the power from the capacitor. You got me? So we're going to talk a little bit more about the switch box. The switch box on a normal application, you could wire in everything directly to the switches and do without all this relay stuff. However, once you get to multiple connections, you do risk damaging components in your car due to power surges and things of that nature. So if you have multiple items hooked up in your vehicle, it's better to do it with a full circuit. So we have each mechanical switch also, and each mechanical switch is going to be tied in with the power from the relay. However, the whole box itself is grounded, therefore the switches will illuminate and indicate which connection I do have active at the time. Next, we're going to talk about this horn pull switch. And you may be asking what the horn pull switch is for. We'll see on this particular application, there's actually a air-powered horn that's actually powered by this air compressor in the car. And what I've done for the horn pull switch is actually a 12 volt pull switch, because it controls a air valve solenoid that operates the horn. When you pull the chain switch, it then in turn acts just like a regular momentary switch and activates the solenoid, which activates the horn, as long as there's air in the tank. And so the way that I wired this horn pull switch is I actually tapped into the stock vehicle horn relay power, which would be more than enough to power this horn switch. I still have my stock horn, and as long as I'm not running my stock horn and this pull switch horn at the same time, it shouldn't risk damaging the circuit. And so now we're going to talk about the power system for the vehicle. So the battery feeds this 4.4 farad capacitor, which is about equivalent to 4,000 watts, give or take. But it's not steady, constant energy coming from this capacitor. It's burst energy. So when the system gets put under load, it bursts the energy to prevent any battery and voltage sag. Also, to recharge all of this vehicle come initially with a 90 amp alternator, and it's been upgraded to a 150 amp alternator that I had from a Subaru Impreza that's no longer running. This is why it's always good to draw a diagram. It puts everything to perspective, kind of helps you draw everything up before you dive into it. On a side note, make sure that you do use the proper gauge wiring when it comes to powering your items. If you use small wiring, it could cause your wires to get hot, overheat, break in half, cause a vehicle fire, and none of that is good. So do use some pretty heavy duty gauge wiring. I always say the bigger the better, because you can't really ever go too big, you know. I've also upgraded the wiring from my alternator to a company that 150 amp alternator, and charged the whole system. So stay tuned with me, and once we get everything starting on the installs, I'll post more videos. And also, by no means, I'm not an expert in the field of vehicle wiring. I've done a lot of research. I've seen what other people do, what works, what lasts the longest, and I took a lot of my inspiration from emergency vehicle lighting, because some of those guys have been doing emergency vehicle lighting for years. They know what works, what does not work, what's safe, and what's not safe to use. So that's definitely helped out a lot.